Have you ever wondered why you never see birds falling off power lines from electric shock? How can millions of volts flow just centimeters beneath a bird's feet without harming it? Imagine this. A power line carrying over 300,000 volts of electricity. Enough energy to power an entire city. Enough electricity to instantly kill a human being. Yet, a tiny bird, weighing less than a slice of bread, lands on that very same wire, and nothing happens. No sparks, no burns, no electrocution. How is that possible? Does the bird have some secret biological insulation? Can birds somehow resist electricity? Or is there a hidden law of physics quietly protecting every bird that lands on a power line? The answer will completely change the way you think about electricity, because the real secret isn't inside the bird. It's inside the electric current itself. Every second, billions of electrons rush through these cables at incredible speed. These aren't harmless wires. Some carry tens of thousands. Others carry hundreds of thousands of volts. If a person accidentally touches one, the result can be fatal. So why doesn't the exact same thing happen to birds? They're touching the wire too. Their feet are in direct contact with the conductor. Shouldn't electricity flow straight through their bodies? Surprisingly, no. And here's where nature meets one of the smartest principles in physics. Electricity is incredibly powerful, but it is also surprisingly selective. Many people think electricity simply attacks anything it touches, but that's not true. Electricity has only one goal: to move from a place of higher electric potential to a place of lower electric potential through a complete path. Think of water in a pipe. Water only flows when there's a difference in pressure. If the pressure is exactly the same at both ends, nothing moves. Electricity behaves in a very similar way. Current only flows when there's a voltage difference and a path for charges to travel. Without that difference, there is essentially no reason for current to pass through an object, and that explains the bird. When the bird lands, both of its feet are touching the same wire. That means both feet are at almost exactly the same electric potential. One foot isn't higher voltage than the other. There's virtually no voltage difference across the bird's body, and without a voltage difference, almost no current flows through it. The bird becomes like someone standing on a perfectly level floor. There's nowhere for electricity to go through its body. Instead, the current continues along the metal wire. Why? Because the wire is a much better conductor than the bird. Electricity always prefers the easiest available path. The bird simply isn't that path. Now here's something most people don't know. Birds can be electrocuted. It happens when they accidentally touch two different electrical potentials at the same time. Imagine a large eagle. Its wingspan is so wide that one wing touches another power line, carrying a different voltage. Or one foot stays on the wire, while a wing touches a grounded metal tower. Now electricity suddenly has what it was waiting for: a complete path. Current enters one side of the bird, passes through its body, and exits through the other side. That's when electrocution occurs. Not because the wire was dangerous, but because the bird unintentionally completed an electrical circuit. So why is it different for humans? Because we're usually connected to the earth. The earth acts as an enormous electrical reservoir. If someone touches a live power line while standing on the ground, electricity suddenly finds an easy route from the wire to the person's body into the ground. The body becomes part of the circuit. That's why electrical safety experts always emphasize avoiding contact with energized wires and maintaining safe distances. It's not simply touching electricity that creates danger. It's becoming part of the path the current wants to take. The bird isn't surviving because it's immune to electricity. It's surviving because it obeys one of the most elegant laws of physics. Electricity doesn't flow just because something is touching a wire. It flows only when there is both a voltage difference and a conductive path. This single principle explains why birds can perch safely, why electricians use insulated tools and specialized procedures, and why engineers design electrical systems with safety in mind. The next time you see a bird resting peacefully on a power line, remember, you're witnessing one of nature's most beautiful demonstrations of physics. Not magic, not luck, but the invisible intelligence of electricity itself. If birds can sit safely on power lines, have you ever wondered why lightning can travel through the sky but doesn't always strike the tallest object? That mystery reveals another incredible secret of electricity. Like, subscribe, and turn on notifications for more mind-blowing science and engineering mysteries.